Okay, pre-lesson. We're up to 2.6, day 2. Now we're going to actually put some of the stuff we learned about the discriminant to practice in a story problem. Now, if you go to example 4 on page 113 in your textbook, there's this problem about this young lady serving a tennis ball. The actual trajectory of the tennis ball makes a parabolic kind of a curve, goes up, then comes down, and it's captured with this little quadratic formula. So all of a sudden, real life hits. Okay, just to break down these pieces, H stands for height. T stands for time, and that's in seconds. So if you think of yourself throwing the ball up after 1/10 of a second, it's probably like right here. And then the harder you throw it, the more time it's in the air, gets to a certain height, comes down. Or you hit the ball at the maximum. So with all that being said, here's this crazy looking formula here, and it's asking you, will the ball reach a height of 4 meters? So they're telling you, hey, the height is 4. So this is a fancy little terminology. We've been using it, but not a whole lot. The height depends on the time. That's what that's saying. So if I put in 1 second, there's going to be a certain height. If I put in 2 seconds, it's going to be a certain height, and on and on and on. So just asks you, will the ball reach a height of 4 meters? So what that's telling us to do is put 4 in for the height. And so then we stick this in here, and the only thing we have left is time. Now, if this is solvable, we're going to notice it in the discriminant. Remember, the square root of a positive number is going to give us some answers. The square root of 0 is going to give us one answer, meaning it's possible. If we get the square root of a negative, not possible. All right. So now what do we got to do to solve this? Well, we're going to subtract 4. Remember, we got to set these equal to 0. So 0 equals negative 5t squared plus 5t minus 2. So here's my A, here's my B, here's my C. Now all they're asking is it even possible? So we're going to go to our discriminant, which is the square root of b squared minus 4ac. And we're just going to plug things in and see what happens. So b squared is 25 minus 4 times a, which is negative 5, times c, which is negative 2. And we look at this and we say, hey, we got the square root of 25. Now a negative times a negative times a negative is going to give us a negative. Now I'm going to forget about the negatives. 4 times 5 is 20. 20 times 2 is 40. As you can see, we're going to get the square root of a negative, which means, guess what? Mathematically, it's not possible. Therefore, it doesn't reach the height of 4 meters. That's a pretty high throw. Now, what about 3 meters? Let me pause this. So, this time, we're just going to set the height equal to 3, see what happens. So now we get 0 equals negative 5t squared plus 5t minus 1. So now, this is our A, this is our B, our C has slightly changed. So b squared, 25, minus 4, times A times C. A is negative 5. This is negative 1. And we can see 4 times 5 times 1 is 20. But because there's 3 negatives, it's going to be minus. So 25 minus 20. And we get the square root of a positive number, meaning, yep, that definitely exists. So the ball does get 3 meters high. So that's how we're going to use the discriminant to kind of answer some of these general questions. So there's phase 1. Okay, so this problem's a little bit more, just a lot less life application. Just seeing if you have a little common sense, seeing if you can work with the discriminant and kind of make sense of it. It's like a wet towel, so you can get some water out of it. All right, so here we go. So the question asks, what value, possibly 2, for B, notice where B is right there, not a 6, that's B, will cause this quadratic to have one real solution. Remember the rules. If the discriminant is positive, you're going to have two real solutions, so we don't want that. If it's negative, it's going to have zero real solutions. We don't want that. The only time you have one, exactly one real solution is when the discriminant equals zero. So with that in mind, we go, okay, this is a basic algebra problem. We need the discriminant to equal zero. See, there's where your common sense, if you've been listening a little bit, should kind of come to your aid. So here's my A, my B is B, my C is 18. So if I plug this in, I get B squared minus 4 times A times C equals 0. Now let's see what happens mathematically. So I get B squared. Now that's 8. 8 times this is 80, and 64 is 144. So minus 144 equals 0. Now if I add 144 to this, both sides, I'm going to get B squared equals 144. Let me check something. Okay? And then we use the old trick. Bada boom, bada bing. Do the right thing. That's where this comes in play. So we're going to get B equals plus or minus 12. So you see it has two possibilities for B in order if we were to plug that back in and then we put it in there, we'd get 0 for both of those, 12 and negative 12. So there you go. Those are the two values. You can see it's a pure algebra problem. All right, last part of the little pre-lesson. Again, there's going to be more sample problems similar to this, but they're going to come at you differently, and you're going to have to use the old noggin. That's what makes this stuff a little challenging. So I've changed the same question up so that it's asking you a different question. So what value or values for B will cause this to have two, here it comes, non-real solutions? This is a different twist. Now watch. We know that if we put our stuff in the discriminant and we get a positive number, it can have two real solutions. We don't want that. If we get a 0, we're only going to get one solution. And if we get a negative, that's where we're going to get our non-real solution. So how do we say this stuff has to be negative? Well, in good old math, we've got this nice little symbol, less than 0. That's a fancy way of saying is negative. So now if we plug our stuff in, we already did that, but B squared minus 4 times A times C has to be less than 0. Now watch this. So we get B squared minus 144 is less than 0. Add 144, we get B squared is less than 144. Now the temptation is to just go bada boom, bada bing, do the right thing. I think we're going to get off the scent if we do that. Now's the time for common sense to kick in. If we look at a number line and we have 0, we know that 12 squared is 144, and we know that negative 12 squared is 144. So if we take a look at negative 12 over here and 12 over here, and we say, hey, if we square negative 12, we get 144 is less than 144. Now, very close, but that's not true. So we'd have to have an open circle here. If we squared 11, that'd be less than 144. Less, negative 11, negative 10, negative 9, negative 8, negative 7, on and on and on. Same thing goes true with 12. If I square 12, I'm going to get 144. So it can't include this, but anything less than that, and I square it, would definitely be less than 144. So what we can conclude about the values, we're not going to get like two numbers like we did in the previous sample. We're going to get a space. So B can be greater than negative 12, but less than 12. Anything in that window, I plug it in here, and then I put that information into the discriminant, I'm going to get something negative. And that's kind of what they're going after. So that's it for the pre-lesson. Don't skip the sample problems because there's different ones in there.